problem. Okay, to solve this problem, what we have to do is we need our reference sheet with the solubility table. Again, you are gonna need this you're gonna have this on your exam, and your exam is gonna look just like this. Okay, it's just gonna be another one of these solubility tables. Okay, so the first thing we wanna do is we wanna break apart all of these molecules and figure out what ions they're made out of. Okay, so if we start with AgOH, you should be able to see that Ag is Ag plus, and OH is going to break down into OH minus. Okay, and again, we get these positives and negative ions by looking at the solubility chart. You can see that Ag is Ag plus and OH is OH minus. Okay, so we just look at this chart and we need to just figure out what ions are on here that come out here. Okay. All right, so I'm going to give you guys a minute. You can work with the person next to you. I want you guys to figure out what this guy, and this guy breaks down into. Okay, so let's take these three. You guys can split them up amongst the people next to you, but I want you guys to figure out what ions they break into. Get some practice doing that. After that, we'll start mixing them together and we'll fill out this table. Yeah, so you were supposed to draw the table and then figure out the ions that they break down to. Yeah, of course. Right now?
Yeah.
No worries.
And then can I get a thumbs up for the stuff that I need to do in there in order to bring your bag?
Yeah, that's fine. Go ahead.
Thank you.
All right, maybe 20 more seconds to break down all of the ions. Alrighty, guys, so if you're finishing, feel free to finish up on your own, but let's start breaking these down. So we have MgBr2. So if we go to our solubility table, we look at Mg. Mg is +2. Br is -1. And so we just need to copy down exactly what we have on the solubility table. So we're going to write that Mg breaks down into Br minus, and it also breaks down into Mg2+. So I'll do the other ones as well. I'll do the positives first. K should be K plus, and Fe is 3+. And then for the negative ions, SO4 is SO4 2-, and OH is OH minus. Okay. So very simple. All we do is break up the ionic compounds with ions from the solubility chart. Any questions about that part? Okay. So from here, same thing as last time, we take the positive of one of them and we combine it with the negative of the other one. So in this box, we're mixing AgOH and K2SO4. So we're going to combine Ag, the positive of one of them, with SO4, the negative of the other one. Since it's +1 and -2, I'm going to need 2 of the Ags, and that gives me Ag2SO4. Okay, and I can tell if it's soluble or insoluble by taking a look at the table. So if I look at the table, I look at Ag and SO4. So if we take a look at it, does this guy dissolve in water or does it not dissolve in water? So if it's slightly soluble, does it form a precipitate or no precipitate? You guys forget. So if it's insoluble or slightly soluble, it does not dissolve in the water. So there is still going to be a precipitate. So for this problem, Ag2SO4, you can write that it is slightly soluble, but this is going to form a precipitate. So I'm going to write a box around it just so that we know this is going to form a precipitate, okay? All right, and then we'll take the other one. We have K plus and we have OH minus, and they're going to combine. So if they combine together, we'll get KOH. You only need one of each to balance it out. And if you guys take a look at the table, does KOH dissolve in water or does it not dissolve in water? K and OH. It does dissolve in water. Thank you to the one person who wants to respond to me. So yeah, KOH dissolves in water. So KOH does not form a precipitate. And so in this question is asking us the formula and name of the precipitates. So all we need to do is write the name of this chemical right here. Ag is silver. And since it's in the middle of the periodic table, we need to put the charge in parentheses. It's going to be silver 1, and this is sulfate. So this is the precipitate. Okay. So pretty much the same thing that we did last time. We're just adding one thing. You just need to write the name of just the precipitate. You don't need to write the name of the soluble stuff. Okay. Okay, we'll do one more together, and I'll have you guys try the other two on your own. And again, if at any point you feel confident doing this, you can just kind of skip ahead, work on it, and then check your answers with me at the end. Okay. All right, so for this problem, what we're going for the next box, we're going to be combining AgOH and MgBr2. So if I take the positive of one and the negative of the other, I'm going to put Mg and SO4 together. And since it's positive 2 and negative 2, they balance each other out. Okay, I'm going to go to the solubility table, look up Mg and SO4, Mg and SO4. It looks like it dissolves in water. So we would write that this guy is soluble, dissolves in water. Okay. Next, we're going to take the positive of the other one and the negative of this one. Put it together, we form KBr. And if you take a look at the solubility table, you should see that KBr is also soluble. It dissolves in water. So since KBr dissolves in water and MgSO4, they both dissolve in water, for this problem, we would just write NP, no precipitate. There's not going to be any solids that form. Okay. All right, so I'll give you guys maybe 5 minutes. You can work on the next two boxes with the person next to you. After that, we'll check our answers, and then that's pretty much it for me today. You'll just have your assignment, which is just a pretty big version of this table here, so it will take some time, but I wanted you guys to get some practice because this is what your exam and your lab are going to look like, okay? So take about 5 minutes, try out the other two boxes, and then we'll go over the answers together. Huh? What? Why? Scared. Get it together, Steph. Come on now. I'm such a bully. Wait, what did I say? I don't even remember. What did I say, Steph? Jack, if you ever want to change seats, let me know. Okay? Sometimes she distracts me. I don't even know what's going on anymore. All right, guys, I'll give you another minute to finish up, and then we'll go over it together. What did I say? She still can't say it. She's so interesting. Goodness. No. You know what? We'll ask you in like 10 minutes. Alrighty, guys, let's go over this problem and then we'll get started on the assignment. Okay, did she finally say it? Okay, I'm gonna ask later, okay? All right, so let's go over this problem and then we'll be all done for the day, okay? So we're gonna take AG and we're gonna take OH from the other one and we're gonna get AgOH. And then for the other problem, we're gonna get Fe and OH3. So it looks like we're going back to the chemicals we just started with. So if we take a look at this table, let's look at AgOH and FeOH. Okay, so if we look at Ag and OH, if you guys notice, the box is blank. So what does it mean if the box is blank? It means the compound does not exist. Okay, so if the compound does not exist, that means it cannot form a precipitate. So if it's AgOH, then we would just say that we can just write no compound. The limit does not exist. Okay, so no compound. Okay, and then for FeOH, we can look at Fe and OH, and it looks like this is insoluble. So we would just put insoluble. And so this would be your precipitate. And then for the name, we would just write iron because it's Fe. Since it's the middle of the periodic table, we need the parentheses. So iron 3, and then the anion is hydroxide. Okay, so the chemical name is iron 3 hydroxide. Any questions about that box? Okay. And then last but not least, we're going to take the positive here and the negative of the other one. So we'll get MgOH2. And then we'll also get FeBr3. And so all we need to do is look at the table for these two compounds. So MgOH, if we look at that, we get Mg, we go to OH. It looks like this one is insoluble. So we would write this as insoluble. And then for Fe and Br, we look at Fe, we look at Br, this one is soluble. Okay, so we have one insoluble and one soluble. So MgOH is our precipitate. And then for the name, we just need to write magnesium. But since Mg has an MCI, we don't need to put the charge in parentheses. So we would write magnesium hydroxide. Okay, and there we go. We are all done. Okay, yeah, I know it's kind of hard to see. I have recorded this and I'll be posting this on Canvas as well. But I'll also leave this up for the duration of the class period so you guys can refer back to it if you guys need an example. Okay. All right, I'll give you guys the rest of the class period to work on this assignment. Again, it is kind of long because there are a lot of boxes. If you guys want to split it with somebody next to you, feel free to do that. But just make sure you guys are getting your practice in because, again, you're going to have to do this on your own for the lab and for the exam. Okay, so I don't mind you guys working with each other, but make sure you guys are getting some practice in on your own. Okay, all right. Good luck on your assignment, guys. Let me know if you want to check your answers or if you want to check the answer key or if you have any questions, okay?